Mining of metal and stone dates back to prehistoric times. These processes are required to obtain materials that cannot be grown agriculturally or created artificially in a laboratory. Modern mining often focuses on ores, including metals, coal, oil, shale, gemstones, limestone, and many more. Many nations have adopted strict regulations to moderate negative effects and to ensure a minimal impact on the environment. The most abundant metal in the Earth's crust is aluminum. Aluminum is naturally found in the form of bauxite, an ore containing aluminum oxide, or alumina. Alcoa mines bauxite from reserves in Australia, Brazil, Suriname, Jamaica, and other parts of the world, processing most of it into alumina. It is extracted from the bauxite through a process called refining. Bauxite is found in deposits around the world, but mostly in the tropics. The formation is sped up by the weathering of aluminous rock. The process to mine bauxite from the ground is destructive to the plants, animals, and landscape of the area. To address these concerns, companies like Alcoa develop a rehabilitation plan before mining even begins. The site will undergo transformations, but Alcoa strives to ensure future sustainability of the land. In most cases, they attempt to return the land to its original condition: forests, swamps, farmland, and grassland. In Western Australia, they set an industry benchmark with mine rehabilitation. Mining occurs in the Jarrah Forest, which is renowned for its diverse flora. The goal is to restore 100% of the species richness to the rehabilitated areas 15 to 18 months after rehabilitation is complete. Alcoa employs a nursery to provide seeds and plants to meet their needs. At another mine in the heart of the Brazilian Amazon, rehabilitation efforts occur in parallel with the mining process. They minimize vegetation removal and maintain genetic material, usually seeds, from threatened species and relocate certain animals to preserve areas. In some cases, such as in Jamaica, rehabilitation is accomplished to support other productive land use, for instance, converting it to farmland. Since most metals are present in ores as oxides or sulfides, the metal needs to be reduced to its metallic form. This can be accomplished through chemical means such as smelting or through electrolyte reduction processes. Inside large carbon-lined horizontal furnaces called pots, alumina is dissolved in a molten sodium aluminum fluoride solution called cryolite. Sending a powerful electric current through the cryolite solution in the smelting pot causes molten aluminum metal to separate from the alumina, falling to the bottom of the pot where it is siphoned out. The metal is then cast into ingots of varying shapes and sizes that are later fabricated into aluminum products. Aluminum smelting requires significant amounts of energy and releases greenhouse gases, but companies are attempting to reduce the negative impacts. More than 2/3 of the energy used globally at Alcoa smelting facilities now comes from renewable sources. In Canada and Iceland, they're powered solely by hydroelectric power. To meet longer-term energy reduction goals, they're researching the availability and potential of harnessing geothermal power. Due to the energy required, aluminum smelting results in the emission of greenhouse gases, primarily carbon dioxide. For over 2 decades, Alcoa has reduced these emissions and achieved long-term reduction goals ahead of schedule. The current goal is to reduce carbon dioxide intensity by 30% by 2020 and by 35% by 2030 from 2005 levels. Spent pot lining, which is generated when the carbon and refractory lining of smelting pots reaches the end of its serviceable life, is also a significant byproduct. Scientists are researching the opportunity to transform spent pot lining into fuels and other raw materials for other industries, such as cement manufacturing, mineral wool production, and brick fabrication. Refining is a process that is required to purify a substance. The aluminum refining process is the intermediary step in converting bauxite into aluminum. In this process, they grind the ore while mixing it with lime and caustic soda. This mixture is pumped into high-pressure containers and heated. the caustic soda dissolves the aluminum oxide, which precipitates from the saturated solution and is washed and heated to drive off water. What remains is white powder called alumina. It's used in chemicals or smelted into aluminum. A significant byproduct of the refining process is bauxite residue, which is mainly sand and mud, with some residual caustic soda and other components. To protect the local environment, bauxite residue must be managed appropriately. Most of the 120 million tons of annual residue must be stored. The goal is for it to be stored in secure earthen impoundments. Alcoa scientists are researching ways to use bauxite residue as a source material in a variety of applications. They develop methods to reduce the environmental footprint of residue storage and chemically render the material so it's more suitable for reuse or long-term management. In Australia, they use a process that converts bauxite residue sand to a product called red sand that can be used as a general fill material, construction backfill, or road-based construction material. One of the world's most sustainable food and beverage containers is the aluminum can. In less than 60 days, they can be recycled and back on the store shelf. In addition, recycling aluminum uses only 5% of the energy required to make new aluminum ingot. Alcoa operates the largest can reclamation facility in the world. This facility alone remelts enough used beverage containers to make billions of new aluminum cans each year. Making new can sheet for beverage containers begins with remelting the material and casting it into ingots that can be nearly 8 meters long and weigh 20 metric tons. Each ingot is sent through a scalper where its surface is shaved for optimization. Then it goes through a series of rolling mills where it's transformed into a thin coil. These thin coils are run through a cold mill at speeds up to 96 kilometers per hour to reduce the gauge of the material to only 26 hundredths of a millimeter thick. In 60 seconds, this plant can produce an aluminum sheet that can make up to 145,000 cans. The final step is trimming the coils on the high-speed slitting equipment and packaging and shipping them to beverage plants around the world. But Alcoa doesn't only deal in aluminum. They manufacture a variety of products that are made of several alloys and metals such as titanium, nickel, and cobalt. To help drive sustainability into numerous downstream industries, Alcoa is the world leader in production of blades and vanes made of advanced superalloys for the high-temperature environments in jet engines and industrial gas turbines. Alcoa uses innovative technologies to design blades and vanes that are capable of operating under higher temperatures, improving overall energy efficiency, reducing noise, emissions, and the overall carbon footprint. The Alcoa Howmet Casting Operations is a leading producer of complex industrial and aerospace fasteners, made from aluminum, corrosion-resistant steels, titanium, superalloys, and more. These fasteners have helped to increase aircraft structural integrity, and in fact, every Airbus A380, the world's largest passenger plane, has over 1 million of these fasteners. Aluminum is an ideal material for transportation applications. It's strong yet lightweight, helping to reduce the overall mass of an aircraft or vehicle to improve fuel economy and reduce carbon emissions. Aluminum is infinitely recyclable, giving manufacturers a sustainable end-of-life solution for their products. For the next generation of single-aisle airplanes, new aluminum alloys and technologies will lower the weight of the plane by up to 10%. The hub of Alcoa's aerospace structures business in Davenport, Iowa, has produced metals for every space vehicle in America's program and all major aircraft, including Air Force One. At the plate mill, they can precisely trim and taper airplane wings up to 37 meters long using giant computerized milling machines. A variety of careers in the industry offer exciting and challenging futures. Lightweight materials technology is a field that is advancing quickly at the demands of many industries. automotive and commercial transportation, air and space travel, and industrial and consumer electronics. Metals are an important part of our society, and thanks to advances in science, we've become efficient at locating and refining metals to fit our ever-growing needs. Aluminum is the most abundant metallic element on Earth and the third most abundant of all elements after oxygen and silicon. We found it to be extremely useful due to its relatively soft, durable, and lightweight properties. Thanks to science, this remarkable metal has proved to be vital to many industries, and the ability to recycle it allows us to take advantage of a sustainable cycle for years to come.